Okay, so let's take each question and discuss them. And as we discuss, the understanding enhances. And all necessary equations we'll bring in as we discuss the questions. Okay. Can you try answering this sample? If an ideal gas is compressed isothermally, then which of the options holds good? No work is done against the gas. The internal energy of the gas will increase. Heat is released by the gas. Pressure does not change. Once you're clear with the concept, no problem. You'll be able to answer it without any difficulty. Yes, sir.
There's an option C.
How is it being compressed?
Isothermal.
Isothermally means is it a slow process or a fast process?
Slow process.
Slow process, right? So let's say I have a system.
Mm-hmm.
The piston is there. When I say I'm compressing it, I'm applying pressure from outside, right?
Correct.
Now what's going to happen? The piston is going to move down, right? I'm going to apply force because
Yes.
of which the piston is going to move down. It's going to move to a, let's say, new position. Right? Earlier, whatever volume it was occupying, now it's going to occupy much lesser volume, correct?
Correct.
The gas is inside. Right? So has pressure increased?
Yes.
Yes, pressure has increased. Volume has decreased?
Yes.
Yes, volume has decreased, correct? So pressure does not change, is not correct. So did we do some work on the gas?
No.
No. Here, when I move the piston, right, work is done.
Correct.
Is there mechanical work done or not?
Yes, sir.
Whether I move the piston down or move it down.
Right, there's work
There is
done.
work done, correct or not?
Yes, sir.
Yes.
Yes, sir.
Is it clear, Samuel?
Yes, sir.
Okay. Now, is it done against the gas or not? Let us see. Okay.
Okay, sir.
Let's talk about what work is done. That is clear?
Yes, sir. That.
Okay, good. Now, heat is released by gas. Internal energy of the gas will increase, right? So the moment I say it is an isothermal process, what process it is? It is a
slow process.
That means there is enough time for any amount of heat generated to dissipate to the surroundings.
Correct.
Is that clear, Samuel?
Yes, sir.
Yes. So point is, obviously, when I increase the pressure, when I do work on the gas, obviously there will be heat generated, correct?
Right, sir.
But that heat will not be consumed by the molecules inside because there is enough time for the heat to be dissipated to the
surroundings.
Is that clear to you?
Yes, sir.
Therefore, what will remain constant in isothermal processes? Internal energy will not be disturbed, correct?
Right.
Why?
Point.
Why?
Energy only is there.
See, whatever heat is generated, right? It will go out. Only when it is absorbed by the molecules inside will their internal energy increase.
Right.
So here in isothermal process, because it's a slow process, the heat that is generated has enough time for it to go out from the system to the surroundings. Is it clear, Samuel?
Yes.
Therefore, what will happen to the molecules? Their internal energy will change or it will not change?
Change.
What? Very simple concept.
It won't change.
Earlier you say it'll change. Now you're saying it won't change. What is your logic? What is behind your answer? What is the logic behind your answer? Be clear about what you're answering and tell me. Don't by heart it and tell. Okay. It's a very simple concept. Go ahead, tell me, ma'am. Now, if you're telling internal energy will increase, I will listen to you, but you should give an explanation. If you say internal energy will not change, you should give me an explanation. Go ahead. Don't just switch between the answers because I'm saying, Go ahead. The idea is you should be clear with the concept. What is an isothermal process?
Temperature is constant.
No, don't go like this, fixed things, okay? I want you to visualize what is an isothermal process. Is it a slow process, fast process? Just look at me, not the book.
The slow process.
Slow process. That means you are moving the piston slowly.
Yes.
Right? Here you are compressing the gas, correct?
Right, sir.
Compressing the gas means what?
Applying pressure.
Applying pressure. What will happen to the volume?
Gets decreased.
Decrease. What will happen to the energy in terms of energy, heat energy, you tell me. When you compress something, what will happen?
The energy slowly gets reduced.
First of all, tell me that the heat energy gets created, right?
Heat energy gets created, yes.
In the
And
sense, when you
it's enough
compress,
time
this
to.
work done is converted into heat energy, correct?
Right. So that has enough time to move to the surroundings.
Sorry?
That has enough time to move towards.
Very good, very good, very good. So that has enough time to move to the surroundings. That is in isothermal process, correct?
Right.
So all the heat that is generated inside is moving to the surroundings.
Right.
Then what will happen to the internal energy of the gas in the system or the system? All the excess heat that is generated is going out. So what will happen to the internal energy of the system?
That decreases.
Why will it decrease? Internal energy means the kinetic energy possessed by the molecules.
Correct.
They are neither absorbing the heat energy nor giving it out, correct or not?
Remains constant.
Extra, whatever they had originally, let's say it is X, okay? Now, because of the compression process, an additional heat Y gets generated.
Correct.
Only if the molecules absorb that energy will their internal energy increase.
Right.
They are not absorbing it. Before that, the heat is comfortably moving out to the surroundings.
Correct.
The excess Y is going out.
Correct.
So what was the internal energy before? X. What is the internal energy now?
Y. X again. So it remains constant basically.
Did you understand clearly?
Yes.
No, yes is not coming confidently. Quickly tell me the process once again. What's happening? Because this must be established, right? Go ahead.
An isothermal process is a process where the temperature of a system remains constant. It is a slow process where the pressure, where the internal energy of a gas does not, of the gas upon compression does not change, and the heat energy, when the work gets converted into heat energy, it has ample amount of time to move towards surroundings, and the volume of the system also decreases when you push the piston down.
Right. You told all the statements, all of that is correct. Now I just want you to emphasize on 2 points, right? So just tell me, answer these questions. I hope you have got it right, but I just want to ensure. So you're applying the pressure, what happens, Samuel? You're doing,
the volume decreases.
You're doing work, right? So volume decreases, correct. What can you talk in terms of the heat energy? What is happening? Now heat energy.
Heat energy has ample amount of time to move towards the surroundings.
So there is an excess heat energy that is created because of the compression process. And that energy has enough time to
move to the
surroundings. So what about the internal energy of the gases inside?
That doesn't change.
That doesn't change because they don't absorb that excess heat.
Right.
Clear, Samuel?
Yes,
so can I say this is wrong?
Yeah.
Is it clear to you? So
yes.
am I doing some work against the gas?
What, sir?
Are we doing work against the expansion of the gas?
Yes.
So no work done is also wrong?
So B is correct.
Heat is released by the gas?
Correct.
Is there heat coming out of the system?
Yes.
Yes. Once your concepts are clear, then I mean, they say, right? Once you are in form, cricket ball will look like a football, right? Do you follow cricket?
Yes, sir.
Yes, okay. So have you heard the statement, right?
Yes, sir.
Yeah. So once you understand all this, it won't, it will be very clear for you. Correct? Is it clear now?
Now clear, sir.
Good. Very good. Let's move on. Okay. In an adiabatic process. So can you tell me a few things about adiabatic process?
So in an adiabatic process, the heat done by the system is constant. That is delta Q equals to 0. And it's a sudden process. It happens very quickly. So there's not enough time for the heat to move consistent to surroundings.
Then what happens?
Then PV is constant.
Now what I'm asking you is, PV is not PV is equal to constant is not the equation for adiabatic process. It's the equation for isothermal, right?
Right.
Okay, what is the equation for adiabatic process? Okay, anyways, so same situation what we discussed in the previous question, right? If this had happened in adiabatic process, had it been not an isothermal compression, but adiabatic compression, can you tell me what would have happened?
Then the heat would not have been released by the gas.
Very good. So what would have happened?
Then the volume would have increased as well. Oh, no, sorry. Volume would have decreased as usual. Then
The question is only about the heat energy, right? So
yeah, that's all. Heat is not released by the
it is
gas.
not released means it is there. What happens? Tell me.
So now so the molecule will now start absorbing that
Very
internal
good. Very
so
good.
that
Go ahead.
starts to increase.
What will increase?
The internal energy.
Very good. In that case, so had it been compressed adiabatically, then the right answer would have been the third option.
Right.
Internal energy of the gas will increase. Is that clear, Samuel?
Yes.
Good. Okay. Now, so what is the equation for adiabatic process, Samuel?
Gamma equals to Cp by Cv.
That's fine. That is the ratio of what is the equation for adiabatic process?
W is equal to Nr into T minus T1 by gamma minus 1.
Okay, please note this down. So what is equation for adiabatic process? PV power gamma is equal to constant. And the gamma power is only for V. PV power gamma is equal to constant. And gamma is, as you rightly said, Cp by Cv. Clear, ma?
Yes.
Okay. So now tell me, in adiabatic process, the state of a gas is changed from P1, V1, T1 to P2, V2, T2. Then which of the following relations is correct? So here in these relations, right? So we know that because PV power gamma is constant, right?
Right, sir.
So P1, V1 power gamma would have been equal to what?
P1, V2 gamma.
No, P2, V2 power
Gamma.
So if that option would have been given, then that would have been the right answer, correct?
Yes.
Okay, but you are not given in terms of pressure and volume. You are given one equation in terms of pressure and volume, right?
Yes, sir.
But that is not correct. That is incorrect, right? So it should have been what?
P1, V1 gamma minus 1 equals to P2, V2 gamma minus 1.
That's what is given, but what should have been there for it to be right?
P1, V1 gamma equals to P2, V2 gamma.
Correct. Therefore, this is not a right answer. Do you understand?
Yes, sir.
Yes. Rest of it, if you see, there are two options which are given with T1, V1, and there is another option given with T1, P1 and T1, V2, right?
Yes, sir.
Okay, logically you can arrive at the answer, right? Very quickly. See here, this will be dimensionally incorrect. Am I right?
Correct.
Because you are multiplying temperature with pressure, power, gamma, right?
Yes.
Here you are multiplying temperature with volume, power, gamma.
Right.
Pressure, power, gamma and volume, power, gamma don't have the same units.
Yeah.
So this equation will be incorrect. Am I right?
Yes, sir.
Yes. You will also understand P1 V1 power gamma is equal to P2 V2 power gamma. If you use any other variable like T and V, if you're going to use, it won't follow the same structure.
Correct.
You won't have T1 V1 power gamma is equal to T2 V2 power gamma. Not possible.
Correct.
So with that logic, even you can eliminate D.
So A is the right answer.
A will be the right answer. But this is through elimination, right?
Right.
But how do you actually get it? Also, I'll tell you. But did you understand my elimination process?
Yes, sir.
Okay. Fine. So let me tell you how you get it, right? Whether it is isothermal process or adiabatic process, we are considering ideal gas. So ideal gas equation will be obeyed.
Right.
PV is equal to nRT is constant for any of these processes that we are considering.
Right.
Is that clear? So,
Yes.
how can I write pressure sample if PV is equal to nRT?
nRT by V.
Yes, nRT by V.
V.
So now, instead of P1, what can I write?
T1.
NR? No. What is P?
Oh, sorry. From P1, V1, T2 to P2, V2, T2. Or P you can just write as nRT by V.
That's what I'm asking. So P
Yes.
here, here in this equation, you have what? P1, right?
Right.
So P1, I can write it as?
nRT1 by V1.
Yes. Into what?
Into V1 to the power gamma.
Is equal to. Similar, tell me for.
nRT2 by V2
Yes.
into V2 to the power of gamma.
V2 to the power of
Gamma.
gamma. That's all you can literally see now. Your answer right there. So NR and NR will
Cancel.
So what are you getting? T1, V1 power. You have
Yeah.
gamma here, you have 1 here. So what does it become?
Gamma minus 1.
Gamma minus 1 is equal to, come on.
D2 V2 into gamma to the power gamma minus 1. So that's the answer.
Is it clear, someone? Take it down.
Done, sir.
Done, huh? Okay. Any doubts on this?
No, sir.
Any doubts? Clear? Okay. Okay. During an adiabatic expansion of 2 moles of a gas, the change in internal energy was found to be minus 50 joules. What would be the work done during the process? Let me try answering this, Samuel.
Thanks.
In an adiabatic expansion of 2 moles of a gas, the change in internal energy was found to be minus 50 joules. What is the work done? Go ahead.
Does it be?
100 joules.
Yes.
Why?
Just a guess.
Okay. See here. First of all, what process is this?
Adiabatic.
Adiabatic process. So let's look at, suppose if the question had been compression, what would be the answer? If it had been expansion, what would be the answer? Anyways, it's an adiabatic process. That's clear, right?
Yeah.
Okay. Adiabatic expansion means what? Very quickly, the gas is being expanded. Expanded means what?
pushed up. That means pressure is being applied from the.
Which means volume increases.
Yeah.
Yeah, ma? You're right. So you are doing work on the gas or gas is doing work?
The gas is doing work.
Yes. Okay. Good. So it pushes the piston up.
Right.
And is this done quickly or slowly?
Quickly.
Quickly. So if it is done quickly, right? See, whenever expansion happens, what can you talk about the heat energy in the system?
The heat energy doesn't move, it stays within the system.
True, true. Now my question is, what happens to the heat energy to begin with? Does it decrease? Does it increase?
Heat energy decreases this time.
Very good, very good. Because when you're expanding, right, you have learned even in sorry, even in your lower class, you have learned, right? Expansion causes
The
causes.
decrease in heat energy. Decrease in heat energy.
Yeah. Expansion causes cooling, correct? Compression causes heating up.
Right.
Right. So when the gas expands, so there is a cooling effect, correct? Or in other words, there is a decrease in the heat energy, correct?
Right, sir.
Because of expansion. Now this heat energy, which is decreased, does not have time to
move out into the surroundings.
Which means additional heat is not allowed into the system, correct or not?
Correct.
So the temperature can be maintained. You get the point?
Yes, sir.
So what would happen, Samuel? This loss in heat.
What, sir?
So there is a loss in heat, right?
Correct.
There is no time for that loss in heat to be compensated by the surroundings.
Yes, sir.
So this loss in heat is taken up by the molecules.
Right.
So what will happen? This loss in heat will appear as decrease in their kind of internal energy.
Right.
Just like when they absorb heat, their internal energy will increase.
But the loss in heat means it decreases.
Yes, yes. That is why you are seeing a negative value, minus 50 joules. Yeah, are you clear?
Yes, sir.
Yeah, so the internal energy decreases by 50 joules. Got it?
Right, sir.
So now the point is how much of work is done.
That's
the question, right? So if you see, if you go to the equation, the quantity of heat that I supply, right,
right,
will be used for two processes, right? What is it? We discussed that, right? Work done plus
delta U.
Energy, correct?
Yes.
So in an adiabatic process, delta Q is 0. This refers to the amount of heat transferred between surroundings and system.
Right.
Because no such thing happens, there is no time for that to happen. So what is delta Q?
0.
In which process?
In an adiabatic process.
In an adiabatic process. Be it compression or expansion.
Right.
So your delta Q will be 0. So that will be equal to delta W plus delta U, right?
Right, sir.
So can you tell me what is your delta W?
Is equal to minus of delta U.
That's it.
So it's just 50 joules.
50 joules. So very simple thing is, whatever loss in internal energy is going to appear as the work done. So that's energy is going to be converted into work done.
Right, sir.
Is it clear, Samuel?
Yes, sir.
Good. So can you tell me a similar scenario in case of compression, adiabatic compression, if I had done, what would have happened?
Delta Q would have still remained 0. But this time the heat energy would have increased.
So the change in internal energy would not be negative, it will be a positive quantity, but work done will be negative.
Yes.
Because we've already seen, if I do work on the system, then that work is considered as negative.
Right.
I have to spend energy, correct?
Yes.
But if work is done by the system,
it's positive.
I take it as it is positive, right? That's why work done here is positive, because the gas inside does the work.
Hmm.
Clear, Samuel?
Yes, sir.
Okay. Had it been isothermal expansion or isothermal compression, what would have happened? Can you tell me?
The temperature would have remained constant, and since it is a slow process, there will be enough time for the heat to move out into the surroundings. So, what happens to internal energy is more molecules start to absorb more internal energy. So, yeah, so
No, don't. Just spot out something which is irrelevant. Which process are you talking about?
isothermal.
Isothermal you're talking about, and you're talking about molecules absorbing energy. Are you getting the point, Samuel?
Yes.
When you're talking about isothermal process,
Mhm.
if I am compressing, what is going to happen? Tell me.
The heat is released.
No, heat is first of all generated, extra heat, and that is going to be having enough time to be
Dissipated into the surroundings.
correct. So, what about the molecules? Will they absorb any heat?
No,
So, what will be the change in internal energy?
it will decrease. Yeah. Sorry, it remains constant.
Well, yeah, you have to get it clearly. In an isothermal process, just like how you're saying temperature will be constant, right?
Right.
Why is the temperature constant? Because kinetic energy of the molecules does not change.
Right.
That's because internal energy cannot change.
Hmm.
Why does the internal energy why does it not change?
Because there is a the heat takes time to move to the surroundings, and molecules do not absorb any heat.
Absolutely, they do not absorb or release energy, right?
Hmm.
An isothermal process. So you should not say internal energy changes. Okay, ma?
Yes.
Are you clear? Okay, good. So any doubts on this? So in that case, delta U would be zero. In an isothermal process, what is zero?
Delta U.
So delta U is
0. But
zero.
yeah,
So delta Q will be W. So your work done will be converted into the heat transferred to the surroundings.
right.
Suppose system does work on the piston, then what will happen? Work done will be positive. That will be appearing as what?
Delta Q.
Delta Q, right? That means heat energy will be absorbed from the system.
Right.
If you're going to do work against the gas molecules, which means you're compressing it, if you do that, then what will happen? Heat energy that is generated will be dissipated to the surroundings. So in that case, the equation will be delta Q is equal to W,
Right.
because delta U will become
0.
zero. Are you clear, Samuel?
Yes, sir.
So in a adiabatic process, what is zero?
Delta Q equals to 0.
In an isothermal process, what is zero?
Delta U equals to 0.
Are you clear?
Yes.
So in an isothermal process, is there a change in internal energy of the system?
No.
No. Is there an increase or decrease in the energy that the molecules possess?
Yes.
In an isothermal process.
Hmm.
In an isothermal process, is there an increase or decrease in energy that the molecules possess?
No.
Why?
Because the molecules do not absorb any heat.
Exactly right. So delta U is zero.
0.
Is there going to be an increase in kinetic energy of the molecules or decrease in kinetic energy of the molecules? Yes or
No. No.
no? No. Is there going to be an increase or decrease in their velocities?
No.
No. Is there an increase or decrease in the temperature of the system?
No.
No, right? So are you clear with this?
Yes, sir.
An adiabatic process, is there whenever work is done on the system or done by the system,
Hmm.
is there a change in internal energy of the system?
No.
In an adiabatic process, when work is done on the system or by the system,
Hmm.
is there a change in internal energy of the molecules?
There is.
No, if I say no, then you say yes. So do not do that. Tell me a reason why. In an adiabatic process, I am doing work on the system or work done by the system.
Hmm.
So talk about the internal energy in adiabatic process.
It changes
Why?
as the molecules start to It doesn't absorb any heat energy. So
Doesn't absorb heat. You're totally messing up isothermal and adiabatic. Just have a clear mind, think about it and answer. Don't by heart and answer. The problem has been you have to unlearn.
right.
You just by hearted some numbers, right? I mean, isothermal temperature constant, like that you have by hearted. That's the problem. Not that it is wrong, but the point is you have not spent time to understand it, so you are not analyzing it. Because without this, thermodynamics doesn't progress, right? That's why I'm saying. Go ahead. Come on, tell me one last time. Adiabatic process, I'm compressing the gas. What is happening? Tell me quick.
There's a loss in heat. And it also appears as a decrease in internal energy.
I'm compressing the gas.
Hmm.
What will happen?
It heats up.
It heats up. Okay. Now go ahead. You're only going to tell about a few things, right? Whether heat is exchanged with the surroundings or not. What is happening to the internal energy? What is happening to the kinetic energy? What is happening to temperature? Only these things you're going to talk about. Go ahead.
So once we compress the gas, it starts heating up, and that heat slowly moves. It quickly moves towards the surroundings. Then
Samuel, wait, Samuel. Haven't we discussed for, I think, not only today, even before, right? When I'm compressing adiabatically, it's a fast process. There is no time for the heat to be dissipated to the surroundings.
yeah,
You said heat is comfortably going out, quickly getting out of the surroundings. Watch what you're answering. Can you tell again? And then we'll move forward.
in an adiabatic process, whenever we compress the gas, the heat energy increases, and there is no time for the heat energy. As it is a fast process, there is no time for the heat energy to move towards the surroundings.
Then what happens?
Then the internal energy does not change. It and then
Samuel, don't see what you're answering, Samuel. If the heat cannot go out, where will it be there? It will be for the gas molecules to absorb it, right? You're saying no internal energy change. Yes, Samuel. Tell me a few points about isothermal process with from your understanding, not from your just from your memory. What is the first point, Samuel? The moment I talk about isothermal, what process is it?
slow process.
Slow process, and there is energy exchange between what?
System and surroundings.
Yes, there is a scope for energy exchange between system and surroundings. Because there is enough time for that to happen. Point number 3. Because any excess energy that is generated or any energy that is heat energy that is going to be, any cooling effect happens or heating effect happens, there is enough time for that excess heat or the lower heat to be shared with the surroundings. Is that clear, Samuel?
Yes.
So that what is to be understood is the gas molecules inside which have internal energy, those gas molecules do not absorb or release any energy.
Right.
Or broadly, I can say system. The gas molecules do not absorb or release energy because they don't have to. Why, Samuel?
Because there's enough time for the heat to
Dissipate to surroundings, right? So if any extra heat is coming and it is dissipating to surroundings, The gas molecules inside do not have to take up the heat.
Right.
So if they don't take up the heat, their internal energy will not change. So change in internal energy will be what?
0.
So because change in internal energy will be 0, there is no change in their kinetic energy.
Right.
If there is no change in the kinetic energy, there will be no change in the temperature also. That's the reason in an isothermal process, change in temperature is 0.
Right.
Is it clear, Samuel?
Yes, sir.
With an isothermal compression or a expansion.
Right.
So if it's a compression, work is done on the gas, correct?
Correct, sir.
If it's expansion, work is done by the gas, correct?
Yes, sir.
Okay, and that will be resulting in quantity of heat given out to the surroundings or absorbed from the surroundings.
Right.
It won't result in what?
Delta U equals to 0.
No, it won't result in change in internal.
Internal energy.
Okay, so can you just summarize this, Samuel?
In an isothermal process, it is a slow process where the energy exchange happens between the system and the surroundings. Here, there is enough time for the heat to be dissipated into the system and from the system to the surrounding. From the system to the surrounding. And the gas molecules in the system, they neither absorb nor release energy. So in that case, there are 3 parameters. The change in internal energy is equal to 0. The change in kinetic energy will also be equal to 0. And the change in temperature is also equal to 0.
Why? Why? So why is delta U 0?
Because as the gas molecules, they don't absorb or release energy.
Yes, so their internal energy is intact and your kinetic energy is directly related to internal energy. Therefore, if the internal energy doesn't change, then the kinetic energy also will not change.
Right.
Kinetic energy is directly
Proportional to
related to
temperature.
temperature.
So that won't change.
Yes, tell me more.
So that also won't change.
Yes, kinetic energy also won't change. Temperature also won't change. This is all in isothermal
Process.
Correct. So can you tell me if I'm doing an isothermal compression? You know what is compression, right?
Yes.
So now tell me what will happen.
It's work done on the gas.
Yeah, so I'm doing work on the gas. So what would be my work done? Is it positive or negative?
It's negative.
Very good, very good. Because I'm doing work on the gas, correct?
Yes.
Okay, good. Work done is negative. Can you tell me what is happening to the internal energy? Can you tell me what is happening to the heat? So as I'm compressing, explain the whole process now.
So this was for expansion, what I explained.
One minute.
So this is just for expansion, what I explained, right?
No, not expansion. This is compression, right?
Previous one.
So previously, sir, you had asked me.
Previously, yes, that's fine. So now you answer it fresh.
Yeah, so.
So
Yeah,
as I'm compressing the gas, what all happens? Tell me.
right.
No,
So
don't refer that. Don't refer. I don't want
yeah,
you to tell from what you understood. That is more important for me.
right. So an isothermal process, once again, a slow process. Here, energy exchange takes place between the system and surroundings, and the heat energy. The heat energy doesn't get released to the system, to the surroundings.
Samuel, this is where I have a problem. Samuel, it's a slow process, correct? You just told heat energy is possible. And now you're telling heat is not released to the surroundings. Why do you say that?
Pink can answer. Sir is asking compression.
Isothermal compression, right? You're only focusing on isothermal. Everything is in front of you. Isothermal compression. You are compressing, right? You're applying pressure. The piston is moving down, correct?
Right.
So what happens? You're compressing. Whenever compression is there, there'll be some heat generated, correct?
Right.
That heat generated, there are only two possibilities, Samuel. Either that heat is eaten up by the molecules inside,
Okay.
or that heat is given out to the system.
Yes.
There are only two possibilities. In an isothermal process, because there is enough time, the excess heat will be given to the
Surroundings.
it is very important, right? What did you answer? You said heat is not shared with the surroundings. So can you come again, Samuel? Go ahead.
In an isothermal process, it is a slow process where energy exchange takes place between system and surroundings. Here, there is enough time for the heat energy to be dissipated into the surroundings. As for the gas molecules in the system, they neither absorb nor can they release energy. So the change in internal energy is zero. As kinetic energy is directly proportional to change in internal energy, that also remains zero. And the temperature, as it is directly proportional to kinetic energy, that also is zero.
What is zero?
Temperature as well.
Temperature is not zero. Change in temperature is zero.
Change.
Change in temperature is zero.
Okay, ma? See here, now also it feels like, you've read through this, that's it. But then, I want you to analyze. Now this is a fresh plate, okay? So we are doing an isothermal expansion. Now tell me, Sam.
Isothermal expansion, it is once again a slow process where the energy change takes place between the system and surroundings. And here the heat produced is, as there is enough time for the...
Samuel. So you're just repeating. You have just now remembered those 3 points. You are repeating those points. Forget those 3 points. Just tell me, casually, normally, in your own words, tell me what is happening here. What am I talking about now? Isothermal?
Expansion.
Yeah, tell me what I'm doing. Let those points be in the background, okay?
Hello.
Okay, ma, are you understanding? So expansion means what you tell me.
That the work is done by the gas.
Very good, very good. So
The
piston
work
goes down.
the W is done is positive.
Yeah, very good. So work done is positive because we're talking about expansion.
Yeah.
Okay, so work done is what, Samuel?
Positive, sir.
Positive. Good work is done by the gas. So what happens? The piston moves up or down?
The piston moves up.
Expansion, right? The
Yes.
piston has moved up. So work done is positive, right, Samuel? Work done is also given by pressure into change in volume. Change in volume is positive because the new volume is greater than the old volume.
Right.
Okay, so change in volume is positive. That's why work done is positive. Now, anyways, now let's talk about whenever expansion happens, what does it cause?
Right.
Whenever expansion happens, what does it cause?
It causes the heat energy to dissipate into the surroundings, and the gas molecules of the system cannot, they can't absorb or release it.
Wait. There is no dissipation of heat into the surroundings here. See, Emma?
Understand.
Expansion causes cooling. Right, Samuel?
Right.
This must get in, right? See, it's like this, right? Suppose in your classroom, which can accommodate, let's say, 50 students, if I put 200 students inside, it's as though, I'm compressing, isn't it?
Yeah.
So don't you feel that the temperature goes up?
Yes.
Or heat energy is generated, correct?
Right.
Well, why do you feel cooler, when you come out? Because, there is more, space, correct or not? So the
Yes.
fundamental law is expansion causes
Cooling.
cooling. Compression causes
Heating.
heating, correct? So here there is no need for the heat to go out to the surroundings. Understood?
Right.
But because now there is cooling automatically happening inside the system. So heat can come from outside to the system. The system will absorb heat from the surroundings. Understood or not?
Right.
Why is it having a tendency to absorb heat from the surroundings?
Because already cooling has occurred in the system since it's
Very good. So are you understanding, Samuel? This is the way you should progress. Got it? Not remembering some few words, okay?
Right.
So what is happening? Expansion you are doing to the gas, so that automatically causes cooling. The moment the air inside is cooled, then that automatically, wants it to be heated up, correct?
Right.
So heat energy will flow from a region of higher heat to lower heat, correct?
Yeah.
So from the surroundings, the heat energy will flow into the system.
Right.
So that whatever was the original temperature will be maintained now too.
Right.
So this cooling effect does not take the energy away from the gas molecules. So
Right.
gas molecules will still have the same internal energy that they had.
Right.
Because the loss in heat is compensated by the heat coming from outside.
Right.
So internal energy of the molecules does not
Change.
Yeah. Are you getting the idea, Samuel?
Yes.
That's why delta U is 0 in this case also. So in
Yeah.
expansion also, isothermal expansion also, delta U is 0. Is it clear, Samuel?
Yes.
Okay, man, go ahead. Fine?
Right.
Okay. So can you summarize all the 4 things in the next 5 minutes? What are the 4 things? You know what the 4 things I'm asking are? What are they?
So in an isothermal
No,
expansion,
what are the 4 things I'm asking you?
work done is positive.
No. I'm asking you 4 things. Isothermal expansion, isothermal compression, adiabatic compression, adiabatic expansion. I want clarity in all the 4. Just few points you can mention. You tell
Okay.
me first of all
Start.
what you're talking about and then tell me. Okay.
I'm talking about isothermal expansion.
Okay. Okay. Think and answer. So what are the points under that?
In
The
isothermal,
definitions don't tell me fixed, ideas.
right.
Just visualize expansion and then talk.
So in isothermal expansion, it is a slow expansion and the work done is positive.
Yeah.
And work done is represented by P delta V, which is also positive.
Yes. Very good.
Here, the energy exchange takes place between the system and the surroundings.
Very good. Mm.
Since it is
So,
a,
so,
they are
so what is happening to the energy? First of all, you should tell.
what's it?
See here, what is the process we are doing?
Isothermal
Isothermal of what?
expansion.
Yeah. So first of all, before you say that heat energy exchange is possible, that's correct. That's true. No doubt about it. What is happening? What is the need for heat energy to be exchanged? There is some change in heat is happening, right?
Right. Yeah.
That you should mention. So what is happening? I not interrupt you. Go ahead.
So here the system will absorb the heat from the surroundings.
Okay. Before that, why is system in a need to absorb heat from the surroundings?
Because expansion causes cooling, so already cooling
Very
is
good. Very good. Very good. Stop. Just pause there. I'm writing. So these are general points. This will be true in case of isothermal as well as adiabatic, right?
right.
So the first point which you mentioned, second point which you mentioned will happen. The moment I say expansion, work done will be positive. Expansion has happened, so it will cause cooling. So these things are common both in isothermal and adiabatic, right?
Yes. Sir.
Now, good so far. Yeah. Now go ahead.
Now here the system will absorb the heat from the surroundings.
Very good. Why is there a need? Because expansion is causing
Cooling.
cooling. So if system does not absorb the heat from the surroundings to the system, what would happen? This cooling
Isothermal compression. Compression.
expansion we are talking about, isn't expansion causes cooling, right?
Yes.
Cooling means what? Loss of heat, correct?
Correct.
So this loss of heat, for it to, because there is cooling happening, what would it result in? If there is no scope for heat energy to come from surroundings to system, it will take away the heat from the molecules.
Right.
Because it's a slow process, heat can come from the surroundings. So what happens? What is happening? Heat is coming from the surroundings. What is not happening? Heat is not lost by the molecules.
Right.
Okay, go ahead.
After that, here the molecules in the system, they neither absorb nor release the heat energy.
Yeah.
So based on that, the 3 parameters are the change in internal energy is equal to 0.
Okay.
Then change in kinetic energy is also equal to 0, as it is directly proportional to change in internal energy. And change in temperature is directly proportional to kinetic energy, so that is also 0. delta T equals to 0.
Okay, nothing wrong about this. I want you to be a little more specific that, so expansion has caused cooling. Now,
Right.
heat energy is absorbed. So come on, so what is the point, Samuel? Heat energy
Is absorbed.
by the system from the surroundings. So the temperature is maintained.
Right.
Yes, ma'am. So no heat energy is lost by the gas molecules. If the fourth point did not happen, if heat is not absorbed by the system from
Heat
the
is
surroundings,
lost from the system.
heat will be lost by the system.
Okay.
That means what will happen?
That means the change in internal energy will decrease.
Internal energy will decrease. Good, good, good. Now you're on track, Samuel. Okay, great. Okay, so now are you understanding, Samuel? You're understanding and answering.
Yes, sir.
Do
Excuse me,
you
sir.
feel so? Do you feel so?
Sorry.
Good, ma'am. Good. Okay. Now tell me about what is the next thing you're talking about? This is good enough. Okay, now final thing, write the equation. Tell me the equation, sir. So you know thermodynamics first law, right? So what is the thermodynamics first law? What is the equation?
Delta Q equals to delta U plus delta W.
Very good, right? Delta U plus I can write simply W. Work done. Right.
Okay.
Now in this case, isothermal expansion, what is happening in Samuel?
Your temperature is constant.
Temperature is constant, correct?
So,
So tell me the equation. What happens to the equation? Tell me. Samuel, you have written down, right? You already told. Haven't you told that delta U is 0? So delta U becomes 0 in this case. So what happens?
So W equals to delta Q.
That's it. Do you understand?
Next page.
The work done is positive. So change in heat energy is positive, meaning to say that heat energy is absorbed by the system from the surroundings.
Right.
So if I give you a question, right? Why I'm saying the equation is the question will be like this, right?
Correct.
The work done, or let's say the amount of heat absorbed by a gas from the surroundings is 100 joules. How much is the work done by the system?
Also 100 joules.
Very good. That's what you understood now. Because
Yes.
delta Q is equal to W. It's not absorbed by the molecule, so their internal energy does not change.
Right.
Clear now?
Yes, sir.
Good. I am also getting a feeling that you're answering more out of understanding than out of some weird memory.
Excuse me, sir.
Yes, ma'am.
Sir, in isothermal expansion, the parameters which I just summarized now, right? Is it the same for isothermal compression? Just a little
I
different.
didn't get it. Could you come again?
So now for isothermal expansion, the
Yeah.
parameters which I mentioned,
Yeah.
is it the same as isothermal compression or does it change, right?
No. See, whether it is isothermal or adiabatic, these will be the parameters we'll be talking about. We won't talk about any new parameter, right?
But isothermal compression means this time it will cause heating, no?
Yeah. So those things will change, correct?
True.
Parameters are the same.
Hmm.
The point is there will be changes, right? So good. Now tell me what are how these things will change.
So I'll start, sir.
Yeah, go ahead.
Okay. So in isothermal compression, yeah.
So visualize the compression. Visualize the compression happening slowly. Then answer these points.
Yes. So isothermal compression, it is a slow process once again, but this time work is done on the system. So work done is negative.
Very good.
And here compression causes heating.
Okay, maybe I can also mention one more point that P delta V, right?
Yeah, heated down.
So here final volume is less than the initial volume, correct?
Correct.
Because it's compression, correct?
Yes.
Volume decreases.
Yes.
So change in volume will be final minus initial value. final value is a lesser value, therefore you get negative.
Right.
Okay, good, go ahead.
And then we also have compression causes heating.
Very good, very good. 1 minute, let me write down. Okay. So here you should remember all these three things. Of course, slow is not true, but all the first two things will be, I mean, the second and third points will be same for adiabatic compression also. You should remember that, right?
Yes.
Okay, beyond this, the change happens, right? So tell me, go ahead.
So there is a change in internal energy of the system.
Why are you going back? Yes, Samuel. Samuel,
Causes
compression
heating.
causes heating, right?
Hmm.
So there is heating up happening, correct?
Correct.
Because it's a slow process, there is enough time for this heat which is generated additionally to
Hmm.
go out to the surroundings.
Correct.
So that it is not absorbed, correct?
Right.
Okay, I'll explain with because you should not, you're again making a mistake, right? You're saying delta U will change. Okay, let me give you an example, right? Okay, now, let us say in this class, I'll give you a typical example, okay? In this class, let's say you are in an adiabatic process.
Right.
Okay. Which means what? Let's say I'm putting pressure on you, let's say.
Hmm.
You are not able to shout at anybody now. I'm
Correct.
just giving a very, what do I say, crude example, but it works, okay? Just if you get it, then you know it's, let's say in this class, let's say I'm asking a lot of questions, putting a lot of pressure on you, okay? Now inside some pressure is building up, correct?
Right.
Now normally if pressure builds up, what do you do? Or if somebody is putting pressure on you, what do you do?
You get mad.
You get mad and you shout, right?
Yes.
Now you are not able to shout, okay?
Right.
Okay, for whatever reason, consider that there is not enough time for shouting. Okay, consider.
Okay.
Okay, so what happens? Doesn't your tension inside build up?
Correct.
If you shout out, you spurt it out, and you're free, correct?
Yes.
But now your energy builds up, yes, or internal energy.
Builds up.
Builds up. This process is adiabatic.
Hmm.
Isothermal. Let's say your mother is trying to put pressure on you. Okay, ma'am.
Yes.
Now what do? You feel that pressure is increasing. Then what do?
You get mad again.
You get mad. That's true. But then you shout out, right?
Yes.
So what happens? You relax. Am I right?
Yes.
That means no change in your internal tension.
Right.
You understand this or not?
So that means no change in internal energy either.
Yes, in isothermal. So when your mother is putting pressure on you, there is no tension building up within you because you're spurting it out, right?
Right.
But let's say it happens with me. I'm putting some pressure on you. Let's say you're not having the same freedom to shout back. So what is happening? Your internal pressure is building up. You get the point, Samuel? Of course, it's a crude example, but then I hope it gets.
It is.
Yes. Now tell me. Yeah. So you're compressing it slowly. So what is happening? Come on, tell me. So your isothermal process, you remember your interaction with your mother. Yeah, go ahead.
So delta U is equal to 0.
Yeah, change in energy will never happen in an isothermal. Got it?
And change in kinetic energy is also 0.
Okay. So are you just answering from what all statements I had given, or you understand, you analyze, you're giving?
Understanding, I'm saying.
Okay, okay.
And delta T equals to 0.
Good.
Okay, what happens? What happens to the heat?
No, see here, compression causes heating, right? Actually, you went to the 5th point before completing the 4th point.
Oh, sorry about that.
See, if heating is happening, there are only two options, Samuel.
Right.
The heat that is generated can be?
It can either be absorbed by system and surroundings, or it can be released from system to surroundings.
Wait, don't add surroundings unnecessarily. Compression causes heating. So the system is getting heated up, right? I mean, there is heat generated in the system, right?
Hmm.
There are two options for the heat to be this effect to be nullified. What can happen? This additional heat that is generated can be
It can be released,
released to the surroundings.
or it can be taken in by the surroundings to the system.
Why the surroundings, sir? Why do you say that?
Surrounding, man.
Or the heat can be lost in the system.
Compression causes heating, right?
Hmm.
Heating is happening within the system, right?
Yes.
So now two things can happen. What are the two things? Tell me. This excess heat which is generated,
Can be released
released to what?
from system to the surrounding.
Correct, right? That is possible. From system to the surroundings, the heat can be released, correct?
Yes.
Or what else is the possibility?
The heat can be taken away from the system.
That's what you're doing in the first case, right? From the system, the heat is lost to the surroundings, correct?
Hmm.
What else is possible? If
The
that
molecules can absorb the
the molecules will absorb the heat.
right.
Do you understand, Samuel? Not from the surroundings. It is within the
Hmm.
system itself. It is heated up, right?
Yes.
So there is no question of surroundings coming into the picture in the second case.
Correct.
Second case, the molecules absorb that heat.
Right.
If molecules absorb that heat, what will happen? Internal energy will change, kinetic energy will change, temperature will change, correct?
Yes.
So out of those two conditions, what is happening here?
The second condition, the molecules are absorbing the
See, in isothermal, there will never be a situation where gas molecules will absorb or release. Isothermal is a slow process, right, Samuel?
yes.
So for any heat that is generated, it has enough time to go to surroundings.
Right.
Why will the molecules absorb heat? In isothermal process, only if there is no other possibility, they will absorb heat.
Right.
Tell me, go ahead. Complete these points. Tell me now. Don't just repeat all those points from the notebook. Just tell me, compression has caused heating now. Clear? Now what happens to this heat? Tell me.
Here this heat in the system is released into the surroundings.
Yes, that's what you should say. Right. That's the only thing you should say. So the additional heat which is generated is released to the
Surroundings.
yes.
Then the delta U equals to 0.
Why?
Delta
Why?
Because there is no change in internal energy.
Why?
Because the gas molecules neither absorb nor do they release energy.
Okay, again you are telling like fixed answers. Yes. In this case, heat additionally generated has been released to the surroundings. The gas molecules haven't absorbed the heat. Correct or not?
Right.
You're not saying anything wrong. What I'm saying is, don't tell from the memory, but just tell from this situation I'm saying. So the additional heat which has been generated, it has only two options. What are the two options?
Either heat is released to the surroundings or the gas molecules have to either absorb the heat.
Not either. They'll have to absorb
They
it.
have to absorb the heat.
Correct. Now, because it is released to the surroundings, the second one does not happen.
Right.
Because second one doesn't happen, because they do not absorb, there is no need for the gas molecules to absorb the heat.
Right.
Internal energy stays intact.
Right.
Are you clear now?
Yes, sir.
Because U is same as before. Change in U is what?
0.
But change in temperature
0.
and change in kinetic energy is also
0.
okay. Now tell me the other two, ma. Yes. What is the third one?
Adiabatic expansion.
Yeah, go ahead.
So an adiabatic expansion is a fast process.
Good. Rapid process or fast process. Visualize. You're talking about expansion.
Right.
Tell me all
So
the points.
work come into the place. Huh? Can
Sorry, ma?
work be, can work also be here in the play? Work done is positive.
Absolutely.
see-
Here, the expansion
So
means
work done is positive.
visualize. So Mr. is moving up, no doubt about it, right?
Right. So work done is positive. So W equals to P delta V, which is positive.
Right. Final volume is more than the initial volume. Correct. Very good. That's common, right? For expansion. Okay, go ahead. Now, what is it? The moment you understand the piston is moving up and work is done, you know that work has been done by the system. Correct.
Yes. Yes.
Now we are focusing on expansion. The moment you see expansion, what is the next?
Expansion causes cooling.
Very good. Expansion causes cooling. Okay, go ahead now. Now cooling means what? Heat energy is lost.
Yes.
Is going to be lost, correct?
So
So
heat
now two
energy is-
options are there. These two options I want you to think and tell me what are the two options. Heat energy is going to be lost, correct?
Yes. So the first option is either heat energy will be released into the surroundings
Here, why the heat energy should be released into the surroundings, Mark?
from system to surroundings.
No, no.
That's the first option.
Within the system itself, cooling is happening.
All right.
Here, when will there be a need for heat to be released from the system to the surroundings? When there is excess heat or less heat?
And there's more heat.
Correct.
There.
Here, is there more heat now?
No.
All right. So there is no point of heat being dissipated to the surroundings. Are you able to understand now?
But the heat should be dissipated on surroundings to the system.
Right. Yeah, that should be absorbed. So the two options, tell me now. So now let's go. Expansion causes cooling. That's clear.
Yes, that's
So
true.
cooling is going to happen within the system, correct?
Correct, sir.
So now the moment cooling is going to happen within the system, what are the two possibilities? Tell me.
One is the heat, if it is more, it will be released from the system to the surroundings. That's one way.
Heat is not more within the system, no. It's cooling, right?
Cooling, man.
I'm just saying if it is more.
No,
No.
if it is, it doesn't come right. Here it is. The system here, because of clarity, if you have clarity, then that's my problem. That's the only thing I'm concerned about, right? See here, you answer from your clarity of ideas. So what is happening? Expansion is happening, Samuel.
Yes.
If expansion is happening, what is it going to cause to the system?
Expansion is happening means heat is going to be released,
No. Tell me from the, so it's
absorbed into the system.
heat is absorbed into the system means temperature will increase. It will cause heat, right?
Yeah.
No, I'm just telling you step by step. Expansion is causing what?
Cooling.
Cooling. So the system is going to experience cooling effect, correct?
Right.
Now, two things can happen at this point. What can happen? Tell me. To compensate for the cooling or to cause the cooling. Tell me. Samuel, listen, Mark. This cooling is happening, right?
Yes.
Listen. Two things can happen. What are the two things? Let me tell you. If I don't allow any energy to transit between the surroundings and system, suppose, then what will happen is the molecules which are inside, right, they will give away their internal energy or they will decrease their internal energy in order to cause this cooling.
Right.
Are you clear, Samuel?
Yes, sir.
Okay. Suppose if that does not happen, then what is the possibility? If there is a possibility for heat energy to come in from the surroundings to the system, then this cooling will be compensated by that heat.
Right.
Are you clear with this?
Yes.
Yes or no?
Yes, sir.
I'm not sure. Okay, go ahead. So expansion causes cooling, right? So which of
Yes.
the two happens? So first tell me what are the two which are possible to happen?
One is the molecules inside the system will, to compensate for this cooling, it will result in the decrease of the internal energy.
Yes.
Or
Good.
the second
Very good.
possibility could be when the heat is transferred on the surroundings towards to the system, that is the cooling is once again compensated as the heat is started to increase in the system.
Very good. Very good. So cooling has happened. Now, either the heat that has to be provided to compensate for this cooling can come from the molecule's energy or from outside.
It has to be from outside.
No. It can be either of the two, correct? That's all.
Hmm.
In this case, which one happens? That's what I'm asking.
The second option.
What?
The heat energy is absorbed by the system and the surroundings.
It does not happen, Samuel, because adiabatic process is a fast process.
No.
So
In a rapid process, there is no scope for heat energy to come out from the surroundings to the system. That much time is not there. I'll give you one more example to make you understand. Suddenly a guest comes to your house. Let's say suddenly I come to your house.
Hmm.
Now let's say your mom has cooked some food.
Hmm.
You don't have enough time to order a Swiggy for me and give it to me.
right.
So what do? Whatever food you have, you give
Share
it.
it.
So there is a decrease in the internal food which is there. Understood or not?
Yes.
But if I give you enough time, right?
Hmm.
I come to your house, then what do? You don't disturb your food which you have made.
You order something else.
Yeah. Do you understand what I'm saying, Samuel?
Right.
Yeah. So please try to connect it and tell me. So expansion, once again, okay, expansion causes cooling. That's clear, right?
That's clear.
Now this cooling can be compensated by two things. What are they?
One is the molecules, it can result in the decrease in the internal energy in order to compensate for the cooling, or the system either absorbs the heat from the surroundings.
That's all, right? So either of the two can happen. One is,
In the first case,
sorry,
the molecules can result in decrease in the internal energy
very good. Why? Because
because already cooling, just to compensate for the cooling.
there are two options are there. Why is one option happening? I'm asking you. So which option is happening? Are you clear about that? What is happening now? Which is happening? Which option is happening? What are the two options with you?
Yeah, I just told the molecules can either result in the decrease in the internal energy.
Neither or either. I'm not able to hear. Don't. Those two words are not required.
Molecules.
Either you use it in the beginning. So two options. Just tell me option one, option two. That's all. What is option one?
Option one is the molecules in the system can, in order to compensate for the cooling, it can reduce the change in internal energy decreases.
Not change in the internal energy.
Sorry,
Internal
decreases. The internal energy decreases.
correct. That's one option. What is the other option?
Or the system can absorb the heat from the surroundings.
Very good. Very good. Right? To compensate for the cooling effect. Very good. Now,
Right.
which of the two happens in an adiabatic expansion and why?
The first option.
Yes. What is the first option? Tell me.
The molecules, in order to compensate for the cooling of the system, have to decrease their own internal energy.
Very good. Very good. Gas molecules decrease their internal energy. Or in other words, simply I can say, come on, tell me, ma. Internal energy decreases. Why? Why this has to happen? Why not the other one?
So because there's very less heat and it's as it is a fast process, it
Not very
doesn't have
less
enough
heat.
time.
Time, yeah.
Sorry, it doesn't have
Now,
enough.
tell me the answer correctly.
Here the change in internal energy will decrease as the adiabatic, since it is an adiabatic process, it does not have enough time
For what?
for the heat to be absorbed into the system
From the
from the surroundings.
good, good, good. So I think you're getting it, right? So Swiggy worked. Okay. So delta U is less than I mean internal energy decreases. What else? Obviously the other things follow.
Also decreases.
Yeah. So I can say internal energy decreases, kinetic energy decreases, then what?
Pressure decreases. Easy.
Is it clear?
Yes.
And
So
then
what
U,
about delta U? Is it the same thing?
so point is why I said the U is decreasing is because
Why?
internal energy decreases, right? So
Correct.
what
Yes.
can you say about change in internal energy? Will it be positive or negative?
Negative.
Negative. What will be change in kinetic energy?
Also negative.
Negative. Change in temperature? Negative, right?
Negative.
Okay.
Right. This.
Because final energy is less than initial energy, correct?
Yes.
Okay, good, good, good. Fine. So is there any heat exchange between the surroundings and the system? Huh?
No, sir.
No. No heat is absorbed from surroundings. Is it clear?
Yes, sir.
Okay, my last one.
Now it is adiabatic compression.
Yes, this you have to give it now with all the expertise you have got.
Yes, sir.
I'm not going to say what you say is right, wrong, nothing, no correction right now. I will just note down what you are saying. I'm sorry. Adiabatic. No looking at your notes, okay? You're answering all from your understanding and knowledge. Even if you make mistake, it's still okay. Fine, go ahead.
In adiabatic compression, it is a slow process, and W is equal to P delta V.
Wait. What process is this?
Adiabatic.
Tell it again. Adiabatic.
In an adiabatic process,
5 times repeat. Adiabatic process is a rapid process. You said slow.
all right, sorry. Adiabatic process,
Finish.
rapid process, adiabatic process, rapid process, adiabatic process, rapid process, adiabatic process, rapid process, adiabatic process, rapid process.
Go ahead. Okay. So what is it? What is the first point? So don't look
It is
at
a rapid process.
what's away right now. Just think and answer. Okay, that's the problem. Okay.
Right.
We're trying to answer adiabatic by looking at isothermal, then so please close all your notes. Just look at the board and slowly answer. Okay. Sorry, I'll not interrupt you. Because if it's wrong, then I have to raise my red flag, right? Okay. So what process it is?
It is an adiabatic process. It's a rapid process.
Yeah.
And the work done is negative. W is equal to P delta V, which is negative. Here, compression causes heating. Here, the heat is released into the surroundings. But it's a rapid process, so no. And there is not enough time for the heat to be released into the surroundings.
Okay, good.
Then no heat transfer, so delta U will remain 0.
I'm forced to stop you and interrupt. Samuel, adiabatic compression, the visualize compression causes heating. So the moment heating comes in, you think of 2 options. What are the 2 options? Tell me.
One is the molecules have to compensate for this heating by increase in internal energy,
Yes.
or it can either result in the heat released by system to the surrounding.
Very good. Excellent. Right? Okay. Now, in an adiabatic process, what happens? And why? Look at me and answer.
Here the molecules need to
Tell me.
already there's heat in the system. So
one of the 2 options will certainly happen, right? Tell me the 2 options again.
right. The molecules, in order to compensate for the heating, will result in the increase in internal energy.
Because of the absorption of heat, right?
Right.
Yeah.
So the first option
can happen.
We have to take the first option.
What is the other option?
The other option was the heat to be released from system to surroundings, but that doesn't happen. Since it is an adiabatic process, the rapid process doesn't have time.
Very good, very good. So this amount of thought you need to spare before you answer. Is that clear, Sambu?
Yes, sir.
And not just by adding those, some conditions, because that you will forget, correct?
Right, sir.
That is not going to give you in-depth thing. So what is the point here? So what is the final point? What is happening?
In order to compensate for the heating, the molecules need to the change in internal energy. It increases for the molecules.
Right. Molecules in the system absorb the heat, right? Absorb this excess heat. Got it?
Right.
And as a result of that, their internal energy,
Increases.
whenever heat energy is absorbed, their internal energy increases, correct?
So
Because of
kinetic
the
energy
kinetic energy increases.
increases, temperature increases. That's all.
And delta values are positive, correct?
Sorry, so what?
No, delta U is positive, delta K is
Yeah.
positive because final value is more than the.
All increases.
Are you clear?
The value is more than initial value.
Clear, Samuel?
Yes.
Very good. Very good. Okay. So, this you should tell me, next when we meet tomorrow also, 5 minutes, I want you to, give it like an adiabatic process, very fast answers.
Right, sir.
Get clarity, okay?
Okay, sir.
Okay, good. Let's move on to the next question. Okay, 100 gram of water. Okay. 100 gram of water is heated from 30 degrees Celsius to 50 degrees Celsius. Ignoring the slight expansion of water, what is the change in its internal energy?
Slight expansion.
Just tell me one thing. What are we doing, ma? We are
Heating the water. 100 grams of water.
heating, right? So that means we are supplying heat energy, correct?
Right.
Now, what it can result in, if you supply heat energy to a system,
Mhm.
it can result in two things. Either both of them happening or one of them happening. So what are the two things possible?
Either the molecules can
Good.
can either increase their internal energy.
Not
Which,
either. No, don't use
sorry,
either.
sorry.
Okay. Tell me. Either already we have put the first.
Mhm.
Forget either or, neither. Everything you forget. Option one. What is option one?
The molecules, in order to
No, there is no in order to. Here. See here. Go from the diagram now. I am providing heat to the system, okay? Now, when I provide heat to the system, two possibilities are there. Tell me what are the two possibilities. Option one.
it results in the change in internal energy of the molecules in the
Okay.
system.
That is option one. Why does it happen? Because there is an additional heat. System can absorb that. Correct?
Yes.
Okay. Next.
Or the system can either release it.
No, here. Anyways, heat is coming into the system that you can't prevent. Okay, ma? So what else can happen?
The heat can be taken away from the system.
No. There is no scope of. See here, you are heating the system. Okay.
Okay.
Now, what is happening is, as you rightly said, internal energy can increase now. Heat is not provided to the system from inside, it's provided from outside.
Correct.
So something has to happen inside only. Whatever has to happen inside only. There are only two options. Do you get the point? It is
Yes.
different from what we discussed earlier. What we discussed earlier is heat is generated inside if there is cooling or expansion. Then there are two options going out to the surroundings and all that comes into picture.
Right.
Here, what is happening? You are supplying heat, ma.
Hmm.
So one option is that heat can be absorbed by the molecules inside, correct?
Right.
So their internal energy can increase, correct?
Hmm.
There's one possibility. What else is possible? Option B. No question of heat coming back to the surroundings, okay?
Mhm.
What else is possible? Think about what else is possible. It is first law of thermodynamics. Work can be
Right.
done
Right. Delta Q equals to delta U plus delta W.
Not delta, delta U plus W.
Hmm.
So do you get it, Samuel?
Yes.
So the excess energy will be utilized in work being done. Work being done means what? Piston will move up. Okay. Are you clear or not?
Clear, sir.
Okay. So you are giving heat energy to the system.
Mm-hmm.
That will result in an increase in heat energy or internal energy or work being done or both. Both can happen.
Yes.
Some quantity of energy that is provided can be used up for increasing the internal energy. Some can be used for what? Doing work.
Right.
So here, okay. What is another way of writing your W?
P delta V.
P delta V, right? Now, ignore the slight expansion of water. That means what should you ignore here in this equation?
Slight expansion of water.
To be ignored.
Internal energy.
Expansion itself talks about change in volume, correct?
So volume we should ignore.
Change in volume you should ignore. Got it?
Okay, so delta Q also delta U then.
That's all. Delta Q is equal to delta U. That's it.
Now they're asking.
They're asking you
delta
change in internal energy. That means they're asking you delta U.
U.
Yes or no?
Correct.
What is delta U? Delta U, correct? Delta Q is equal to
Delta U, yes.
delta U, right? Delta Q directly they have not given you. They have given you some parameters.
Yes. The split heat of water.
So how do you find delta Q from the given data? There is a formula, mass into specific heat into change in temperature. Note it down. So what is delta Q equal to?
MS delta T.
Okay. Have you seen this formula before?
Not really, sir.
Okay.
Actually, first time.
Mass. What is the mass?
100 grams.
Yeah, just substitute.
100 into specific capacity, it's 4
Make it in
okay.
kg because it's your specific capacity is given per kg, right?
Yes.
Yeah.
Into
What is the
484.
Yeah,
4184. Now delta T is from 30 degrees to 50 degrees.
Yeah. So what is the change?
20.
20. So there is no need to convert from degree to Kelvin here because when you are subtracting, whether you subtract Kelvin temperatures or degree Celsius, the difference will be same, right?
Right, sir.
That's all.
Okay.
So just if you multiply by 2, what do you get? Suppose approximately if I take this as 4,200 joules, right? Into 2 is what?
8400 joules.
Or
But
in
that is
other words,
to kilojoules. 8.4.
so did you understand, Samuel? Yeah. So specific heat refers to the amount of heat required to increase the temperature of 1 kg of a substance by 1 Kelvin.
So this is specific heat capacity definition.
Yeah. So I've given you one data, right?
Right, yes.
I've given you specific heat of water as 4184 joules per kilogram per Kelvin. So what is the definition of specific heat? So specific heat capacity is the amount of heat required
to increase
to raise
temperature.
the temperature of 1 kg of a substance through a temperature of how much? 1 Kelvin. Or 1 degree Celsius. It doesn't make a difference.
Right, sir.
Let's say, what does this mean? If I have 1 kg of water, if the present temperature is 25 degrees Celsius, if I want to make the temperature of the water to 26 degrees Celsius, that means how much rise?
1.
1 degree Celsius rise in temperature. what is the mass of water I have?
100 grams.
No. I'm talking about specific heat capacity. No?
Oh, okay.
1 kg of water I have. I want to increase its temperature from 25 degree to 26 degrees
Yeah,
Celsius.
1000 grams of water.
I have 1000 grams of water, right? So how much energy should I supply? See, for raising the temperature, you have to supply heat, right?
Yes, so M is delta T. The
I
formula.
have to supply 4184 joules. That's the meaning.
Right, yeah.
Okay. Suppose you want to raise the temperature by 2 degrees Celsius of 1 kg. Then I just have to supply double this heat. I'm telling you the logic behind this.
Right, yeah.
Okay, fine. So we'll move on. Is this clear to you?
Yes, sir.
Yeah. This you have to answer. Put in some thought.
Sorry.
Yeah. Figure shows 4 PV diagrams, pressure and volume diagrams. Which of these curves represent isothermal and adiabatic process? Which represents first answer should be isothermal, second answer should be adiabatic.
So it can either be compression or expansion, right?
It can be either compression or expansion because they only mention isothermal and adiabatic process.
Okay. So I'll just come back to this.
Okay, sure.
Thanks.
Okay. Figure shows 4 PV diagrams. Now, which of these curves represent isothermal and adiabatic process?
So is it option A, D and C?
D and C. Can you tell me what is your basis, ma'am?
So because for A and B, the graphs drawn, it's from the negative part of that side. So I just made random guess.
Okay, no problem. Let me explain to you. See, here A and B, as you said, cannot be the answers because if you look at your equation, right?
Yes.
P is equal to nRT.
Hmm.
Your nR are constants, right?
Right.
And if I'm talking about adiabatic process, then the temperature is constant, correct?
Correct, sir.
Okay, ma'am. Then what will happen is, if I increase the pressure, right? See here, you can also visualize the system, right? When I'm applying pressure on the system, volume decreases, right?
Correct, sir.
Correct. So you cannot have a relationship where pressure is also increasing, volume is also increasing, correct?
Right, sir.
So when pressure increases, volume must
Decrease.
correct. So if you see in A, both X is increasing, Y is also increasing, correct or not?
Yes.
So that means volume is increasing, pressure is also increasing. That is not possible, correct?
Correct.
Same is the case with B also.
Yes.
So what is happening?
Volume
Pressure
increases.
is increasing, volume is also increasing, correct?
So A and B not possible.
So that you can keep it away, right?
Right.
So that itself will give us the answer as first option.
Yes.
Correct? Okay, anyways. But now let's analyze. Isothermal process, so it's C or D, right?
Right.
So one has to be isothermal, another has to be adiabatic, right?
Correct, sir.
Isothermal process is what?
Slow process.
Adiabatic process?
Fast process or rapid process.
Right. Now if you see, this shows rapid decline.
Right.
This shows a gradual decline, right?
Yeah.
So gradual one is what?
Isothermal.
And the
Rapid one is adiabatic.
isn't it?
Yes.
That's so that shows you it is going to be D and C. Is it clear, Samuel?
Yes. Sir.
Okay, good. So let's move on to the next now. When heat is given to a gas in an isothermal change, what will this result in? No, just from your knowledge, you answer, Samuel. No need to refer.
Okay, heat is given to a gas. So this has to be isothermal expansion. Because isothermal change. So let's say result will be external work done, rise in temperature, increase in internal energy, external work done, and also rise in temperature. Pretty nice. External work is done. Rise in temperature.
Yes, Samuel. But I think you should answer this because, right? Because if you have really understood, then you should analyze and answer. Don't just look at your whatever we've done so far. From whatever you understand, right? Or from your memory, whatever it is, answer.
That's it, option A.
Option A is correct. Okay. Logic behind that?
What?
No, I'm not able to hear you, ma.
Oh,
Because work done is positive. Since it is an expansion causes cooling. So work done is positive on the system. It's like isothermal expansion.
Okay, ma. So why not D? D is also saying it's external work done, right?
Yes, but it's saying
And
rise
why
in
is it? Why is
temperature.
it
That's
not?
not
Why
possible.
shouldn't Anama?
But it's saying rise in temperature, but that's not possible.
Why?
Because if delta U, that is change in internal energy, is zero, then kinetic energy also zero. Temperature also zero.
Okay, correct. Okay, fine. So the point is this, right?
Right.
Samuel, if I did not mention isothermal, right? If I did not mention isothermal or adiabatic, then what is possible?
What's it? You didn't mention.
If I did not mention, see, understand. So I'm giving heat to the system, right?
Okay.
So it can result in two things, right?
Yes.
What are they?
One, the molecules can either decrease, increase.
Oh, either. Don't use either, neither in between.
No. The molecules can decrease their heat in internal.
No,
Sorry.
I'm giving heat energy to the system, right?
So they can either increase
Oh,
the
either, not forget it. Option one. What is option one?
option one, molecules can increase their heat energy.
Increase their internal energy.
Internal energy, sorry. Internal energy.
Okay, option two.
So, but you're saying you're supplying heat to the system, right?
Right.
So there can't be an option for system to release the heat.
Good. Okay. So what can I do? System can do work. The piston will move up. First law of thermodynamics.
Delta Q equals delta U plus W.
You're giving heat to the system. It can appear as what? Increase in internal energy. Listen. It can appear in it can result in increase in the heat, internal energy, or it can be converted into what?
Or can work, yes.
That means the piston moves up. I'm just giving a simple example of system with this
That's
piston system, right?
Yes.
Piston and cylinder system. So this kind of conveys, how a thermodynamical system works, correct?
Yes.
So in general, if I did not give it an isothermal change, then what will be the answer?
Adiabatic change. Sorry.
Say isothermal or adiabatic specific. And gate is given to a system, I simply say that.
So it should be B then. D then.
D, yeah. Result can be
D.
external work done and also rise in temperature, usually, right?
Yes.
But because I mentioned it's an isothermal change, then what happens is?
Only external work is done.
Yes, because
delta U is zero.
change in internal energy, because whatever heat that I'm providing is converted into work. So the gas molecules don't have to absorb their energy.
Right.
Is that clear? So external work done, right? Suppose the same question, if I make a change, I give heat to the gas in an adiabatic change.
Adiabatic change. So there's no time for the heat to move out into the from system to surroundings. Okay. But the what is the first terms?
No, in an
Then
enema?
they're just telling the two options, what happens. Okay. First option is
Probably I'll give a simpler question so that you will answer that. What is a simpler question? I'm doing the reverse. I'm pressing the piston down.
compression. Okay.
I do some work. So what is going to happen?
So work done is negative.
Work done is negative, correct. So what will it result in? Will it result in increase in internal energy, a rise in temperature?
No.
Will it result in heat being dissipated to the surroundings? Will it result in both internal
No.
energy increase as well as heat being dissipated to the surroundings? An adiabatic change.
It will.
What will happen?
The heat is it gets dissipated into the surroundings.
Sir, in adiabatic, there is no time for that. Yes, Samuel.
Didn't you write it down?
So heat will not be dissipated to the surroundings. It will be absorbed. It will be absorbed by the system. Internal energy will increase. Temperature will increase. Okay.
Right.
Okay. Fine. So today I may need to stop it.